homework solutions to the Chapter 4 projectile problems. Again, these are only the first few sections of Chapter 4, but I wanted to assign a few problems, go over a few of those. Hopefully this scan looks better. They did fix the scanners here at school, so it looks a little more professional than me taking with my phone. At any rate, for problem 49, you're basically given how far an object moved on a horizontally when it was shot at a 20-degree angle, and your goal was to find the initial velocity with which it was shot and then the maximum height. So we can use this range formula, which I mentioned in class, rearrange it to solve for VO. So that VO was 12.3 meters per second. Then, in order to figure out the maximum height, we need to split this up to, I would say normally it's vertical and horizontal components, excuse me, but we really only need the vertical component. So its initial velocity times the sine of 20 degrees tells us initially we're moving up at 4.2 meters per second. So if we do that, and we know that at the tippy top, we're going 4.21, or we're going 0 meters per second. We started at 4.21, gravity's down, then I can solve for that delta y. We get 0.9 meters. You could have also thought about this due to the symmetry of the problem as VF on the way down, right before it hits the ground, as being 4.21 and VO at the top. And that way you can just use G as a positive 9.8. So you shouldn't end up with a maximum height that's negative. But again, you think of the first half or the second half of the problem. For problem 52, you basically have a tennis ball that's shot at 20 or hit at 20 meters per second, 2 meters above the ground, 5-degree angle, and the question is can it clear a 1.0 meter net? First thing I do, split things up into the vertical and horizontal components. So I get a vertical component of 1.74 meters per second up, horizontal of 19.9 meters per second sideways. Not sure why that looks smeary. Must have been a scanning issue. Okay. Then I want to find the time that's going to take to hit that, to get to that spot that's the net. So I'm thinking horizontally, so there's no acceleration. So 7 meters divided by the horizontal speed is me 0.35 seconds. Then I can find the change in vertical position during that time. Or I could find the final vertical position after 0.35 seconds, which is what I did. So it was hit initially at 2 meters, 1.74 meters per second up times 0.35 seconds, 1/2 negative 9.8 times 0.35 squared down. So that means that at 0.35 seconds, it's going to be 2.01 meters above the ground. And it definitely clears the net. It actually is just a tiny little bit higher than where it was hit. So kind of a symmetrical problem there. This one I think was one of the tougher ones because you really had to think about that using some math and trig and things. Initially I was a little uncertain. So basically it says, hey, an arrow was shot 60 meters away, it hit the ground at 3 degrees, and your goal was to figure out the launch speed. So I'm thinking, holy cow, I don't have enough information. However, one of the things I can do is I can realize that this 3-degree angle at the time it hits are components of both the vertical and horizontal velocity. The horizontal velocity doesn't change, the vertical velocity does. So I can think about the fact that the horizontal velocity is 60 meters divided by t. I can also think about the fact that the vertical velocity after that amount of time t is going to equal 9.8 meters per second squared times t. So then I can say the tangent of 3 degrees, which is opposite over adjacent, is equal to 9.8 t, that's the vertical velocity, all that over 60 divided by t. So kind of cool how I can do that. Like I know very little information, but that angle is super helpful. So I rearrange that, I get 9.8 t squared over 60 is equal to tangent of 3 degrees. So I end up 9.8 t squared equals tan 3 times 60. T squared is 0.32. T is equal to 0.566 seconds. So now, if I want to find the launch speed, I can say 60 meters divided by 0.566 seconds, that's my launch speed. This question could have also asked the height at which the arrow was shot. Again, if you're falling for 0.566 seconds, you could just do a y equals 1/2 at squared for that. Problem 56 is you've got some sand coming off a conveyor belt at 15 degrees below the horizontal. You need to find this distance that it's away from the cup or the vessel where it's going into. Again, like with many projectile problems, if I'm given this initial information, I'm going to split it into horizontal and vertical components initially. So the horizontal component is 6 meters per second times cos of 15 degrees, and that's 5.8 meters per second horizontally. The vertical component, 6 times sine of 15 degrees, that's 1.55 meters per second down. So next, I need to figure out the time it's going to take to enter the cup. There's a couple ways you could do this. I'm going to find the final vertical velocity using this formula. Vf equals Vf squared equals Vo squared plus 2a. In this case, it's delta y. So I've got Vf squared vertically is equal to 1.55 squared is my initial vertical velocity. So I'm not thinking the 6 or the 5.8. Plus 2 times 9.8, and it said this was a 3 meter dropping distance. So when I do that, I get my final vertical velocity, 7.82 meters per second. And now I can just use this formula, which is change in velocity over acceleration is equal to time for an object undergoing uniform acceleration. So change in vertical velocity divided by g, and that's 0.64 seconds. So now 0.64 seconds multiplied by the horizontal component of speed or the velocity, and I get that it's 3.71 meters away. So if you notice here, both these last two problems aren't asking for time, but you really kind of need to find time to be able to answer the question. So those are some more complicated projectile problems. Hopefully those help.